There we go.
Yes, it's a full screen phenomenon. Your background looks great. Your audio is good. Sean, how's your audio?
How's that? Good?
Perfect. God, crystal clear.
Okay, right. Cool. I can't actually navigate to Zoom. Oh, there, maybe that's it. As soon as I click on the icon, my workspace flips over. Oh, there we go. Okay, now I'm viewing your screen down. Good.
All right, we'll start as soon as you can share your screen. Yes.
Okay.
Oh, wow. Live video feed. All right. Okay. All right, we are good to go. Fabulous. All right, everybody who's joining us today, thank you so much. Cool. We got a good crowd of folks in the room. So if this is your first time joining us, this might be your 16th time. This is Lunchbox. It's our Mapbox weekly live stream where we show something cool. Sometimes we do live coding, and today we're going to be doing this demo of a DIY IoT project that Tom hacked in his basement or home. And if you are tuned into Twitch for the first time, make sure to log in because we do a presentation. We also take a lot of questions and answers, and that's some of the funnest part of what we do here in these sessions. Lunchbox is our way of just connecting with each other while we're all working remotely in the same way that we would in the office, just to share whatever it is we're working on. That's cool. I'm really excited about today's project. I first spotted it on Twitter because Tom Lee, our policy lead, is super fun to follow on Twitter. Is your handle TJL on Twitter?
It is, yeah.
All right, cool. Yeah, if you're not following Tom and you're on Twitter, go to TJL and check out some of his projects and his commentary. I'm going to hand it to the two of you. Our moderator today is Sean Breen from our sales team. And I heard that the two of you talk a lot about this DIY hacking situation. So I'm going to leave it to you to tell us what Mapbox APIs have to do with these objects in your basement. Take it away, Tom.
Yeah, thank you. You know, as Dom said, these days I'm policy lead at Mapbox, which means I'm mostly writing emails to lawyers. But in my early days at Mapbox, I was doing engineering on our search team, and I still need to scratch the coding itch from time to time, mostly through this hardware hacking hobby. And yeah, this was a little project that addressed a concrete need, but kind of spiraled out of control, and eventually came to encompass some Mapbox APIs in a way that I thought was pretty cool. So I'm excited to talk to you about today. Sean, do you want to tell these nice people who you are, how you got here?
Yeah, sure. Thanks. So I'm Sean. I work with our customers, and surprisingly, I spend a lot of my time writing emails to lawyers too. So maybe we do a similar job, Tom. But as Dom alluded to, Tom and I both like to kind of tinker around in various things. And increasingly, I've been looking into coding and 3D printing. It kind of connects to our job. And today we're hoping to show you how it directly connects to our job. So I'm here in the comments, and we hope to make this a discussion. So we're looking forward to it. Thanks.
Cool. So let me do a little bit of scene setting. Like a lot of other people, our household here has been struggling with juggling childcare and work. I've got a 3-year-old and a 1-year-old girl who we love to pieces, but man, it is hard to keep them occupied during the workday and get things done. We were extremely lucky that my sister-in-law was available to give us a hand at the beginning of this weird outbreak time. I think everyone between our families agreed, like her job, which was very customer facing, was probably not the best thing to keep doing. So she took a leave of absence, and we were able to hire her to help us with the girls and to bring her niece over and kind of form our own little unit, which was great. And every night we would lend them our car to drive home, and then they drive back in the morning. We had our own little like quarantine household. But those morning minutes before that car came back could be kind of frantic, as my wife and I came downstairs, started answering emails and phone calls, and like it was top of mind how long it was going to be before we had help. At the same time, I was very sad to get an email from a long-standing Mapbox customer called Automatic, which was always impossible to Google for, and probably more so now. But they made this great little device that you could plug into your car, and I had one, that would let you get like analytics about fuel efficiency and tell you where you parked and like get stop-start events, all kinds of fun stuff. It was really useful when you were sharing a car across the household and like needed to know, I should put dinner on now because they're leaving daycare at this point. So I was really bummed that this thing was going away at exactly the time that we needed it to inform this morning process. Fortunately, going back to Twitter, someone told me, there's like versions of this you can hack together yourself. And that put me on a long quest. So that's what I want to talk about today. It's a process of replacing what Automatic did with, I won't say open source exactly, but like commodity aftermarket components, and then hooking it up to some pretty fun stuff to add functionality. And what you're looking at on my screen right now is kind of the endpoint. These are some ambient displays. I'd already built these. Actually, you should ignore the duck head and the meter on the left, but the laser cut box with the yellow light and the meter on the right with the blue LED are what we're going to be talking about today. These are projects I built ages before, but they were just gathering dust. They weren't hooked up to anything. They stopped working, and I realized I could connect them again. So, okay, let's talk about the pieces here. I'm going to start with the beginning of the system and then the end of the system, and then we're going to kind of fill in the connective tissue between to talk about how all this works. Let's start with the GPS tracker. This is the hilariously named Sinotrack ST90B, 902B. This is a little dongle you plug into the OBD2 port on your car. It's if you've ever gone to get your emissions tested, they probably plug something in down there. Same thing. This thing costs 20 or 30 bucks, and it takes a SIM card. So you can sign up for like a $5 a month plan. And once the SIM card's in there, it's plugged in your car. You actually program it by sending text messages to the phone number of the SIM card, structured in a specific way. So you say like, hey, I want you to send your data to this server. And then every 30 seconds, it's gonna ping whatever you pointed it at. And in this case, it's pointed at a Raspberry Pi that is sitting under the couch to my left. That Raspberry Pi does a bunch of things we're going to talk about, but let me see. Here we go. These are the outputs, and these are actually fairly different in terms of their hardware. Let's start with the yellow light because this is the simplest of the two. If you forget about the laser cut box, which we won't talk about, it's really just on off, right? In its initial iteration, this was running with a Raspberry Pi. I left it in there because it's now antiquated and it was kind of bolted down, but it's dead. Ignore that Raspberry Pi in the picture. What's inside the box are two things really, besides the USB power supply and the extension cord. One is a solid state relay. This is just a way of switching on and off AC current. And the other is this little doohickey. This is a microcontroller. It is a Wemos D1 Mini. That's one of many different chips built on the ESP8266 chipset, which has kind of taken the hobbyist world by storm in the last few years. It's really small, as you can see. This whole thing is a little bigger than a postage stamp, costs between $3 and $4. That's a micro USB cable to give you a sense of scale. The cool thing about the ESP, besides being very cheap and being able to be programmed in the Arduino environment, is that it has built-in Wi-Fi. That little rectangular squiggly thing on the side is a Wi-Fi antenna. So it can do a bunch of the things normal Arduino can, and it can also like give you Wi-Fi for free, which is great. So that, oh, and I should add, like that yellow cord right there is connected to the relay, and you need to have a ground connection as well. But this is basically as simple as possible. The code is just saying like on or off. That's it. The meter is a little more complicated. This was something I built for my wife when we were still dating. And it was to help figure out when the bus was like when it was time for us to run out the door to catch the bus in the morning. It's got two capabilities really. One is this vintage voltmeter that I bought off of eBay. I had kind of a vintage voltmeter problem for a little while there, and still have a few baskets. If you search for the keywords are vintage voltmeter and lot, and you will get a bunch of garbage and a bunch of beautiful ones like this. But so this can be controlled by the hardware inside. And then the other thing that's there is a RGB LED. So you can control the color of this. And I'll get into this a little bit more, but like today I would use totally different technology to do this. They actually build the microcontroller into the LED today. But even just 5 years ago, it was like a whole different world. And this is the bottom of that meter. You can see I didn't bother putting a base on it. It is a generation 1 Raspberry Pi before they had Wi-Fi built in. There is an Arduino in here too to do some of the housekeeping with the meter and the LED. It's not worth getting into specifics. I didn't replace any of that stuff because it more or less works. So those are the two ends of the system. Let's fill in some of the details in between. There are a zillion of these OBD2 dongles that can do GPS tracking for the like worried parent / worried child of elderly parent markets. The open source project that speaks to the most of them is this thing called TrackCar, which is it's designed for managing fleets. Really, it is a many years long project. It's very impressive in its way, but it's designed for managing like a ton of different vehicles at the same time and it's a little bit awkward to deal with. Also, it's written in Java, which I haven't written since high school. So if I wanted to customize it, I was not loving it. Fortunately, TrackCar, its big advantage is that it can speak to all those different adapters, right? Many of which have their own dialect. There's like literally more than 100 that supports, including the one that I bought. Fortunately, there are some good options. So I'm going to connect to the Raspberry Pi that runs all this stuff and just show you real quick how TrackCar can be made to give up its secrets. If you look down here on like lines 26 through 30, you can just configure TrackCar to say like, hey, I know you're doing a whole bunch of stuff with this interesting information you're getting. Could you also just forward it to this IP address? And in this case, I'm just forwarding it to the same machine, but on a different port. What happens on that port is the bulk of my project. You know, at Mapbox, we write a lot of JavaScript, but Python is still kind of the thing I'm most comfortable with, has most batteries included. So I wrote this one script using just the very default HTTP server library that ships with Python to handle those incoming events from TrackCar on the server. And when they come in, they are like long query strings that contain the latitude, longitude, speed, and a bunch of other things I didn't bother with or really understand. But each one gets served like a conventional web request. You can do a bunch of different things with it. This script really has two primary outputs. So the first is outputting to what's called an MQTT server. We'll get into this more later, but this is a technology that basically is if any of your web developers have done like a WebSockets echo test demo, pretty much the same thing, but designed for low bandwidth IoT devices, very efficient. And basically you can publish messages to what's called a topic, which are arranged hierarchically, and you can have any number of subscribers to that topic who will get the message as long as they're connected. There's a bunch of other convenient stuff. Basically, like if you want to do a pub sub setup, MQTT is great, and this is a very simple way of using it. And then the other thing that I do is send some pushover notifications. And pushover, I will highly recommend to any devs who aren't using it here. It's a really cool Swiss Army knife for getting push notifications on whatever device you want. So I can maybe demo this real quick. If I, this is using the command line tool curl to just send a request to the pushover API using a API key I will delete after this. Like it should send a notification. Oh, well, it just showed up on my phone. You'll have to take my word for it. Here, I've got some slides of what these actually look like. But you can get push notifications using this without like going through the App Store process or building your own thing. So this is what it looks like when I start up the script. When I click on that, this is what I wind up getting. And it also comes through to my Apple Watch, which is pretty cool, I think, controlling for whether or not Apple Watches are cool at all. So
they are. I think they are.
So okay. So those are the two main things that the script is going to do. Let's talk about sort of the specifics of what it does. It is going to tell me when the car starts moving, when it stops moving, and it's going to try and provide some useful information besides that, as well as like some fancier ambient display things. And this is where the Mapbox connection comes in, and where I was like, you know, look, I am wearing a Mapbox t-shirt. So obviously I'm in the can for these guys, even if I didn't work here, but it's really a pleasure to work with these APIs and to do some things that otherwise would be a huge pain in the butt. So there are a few different things that I use Mapbox for here. The first is reverse geocoding. When I park somewhere, I want to get the address of the place because then I can just kind of remember like, oh, it must be street sweeping. My wife parked the car one block over on, you know, on First Street or whatever. To make that request is really simple. I fetch it here. It's called a reverse geocode. That means we're starting with the longitude and latitude and getting back a street address. Here is the actual query. I'm just going to open it in a browser window because we can take a look at the JSON there.
While this is loading,
yeah,
I have a question. How many Raspberry Pis do you think you have running in your house, dead or alive?
Well, running at least 3. We've got one on the 3D printer. There's one that's managing the meter downstairs, and there's the one that we're SSH'd into right now. But I definitely have some non-functional ones in a drawer.
So I had to know.
Yeah, so I'll say half dozen maybe. But okay, so here's our API response. Let me make this a little bigger, and you can see I'm just here I put in the lat long for Mapbox's offices downtown. We get back a really nice street address, and if I look for the fetch geocode call, I'm just passing it this stuff and doing a little bit of cleanup because I don't always need to be told that I'm in Washington, D.C. Like I know that for most of the things. So okay, geocoding is pretty straightforward. You may have noticed the lovely maps that accompany those push notifications. This is something else that Automatic did really well. I already mentioned they're a Mapbox customer, of course, or were. I use our static map API for this. Static maps is a way of getting a ping or a JPEG or other static file image version of the fancy map style that you designed elsewhere. And it's really seamless. You don't have to do anything else. If you built a style and you've got it in your application, you can just get these things generated automatically by our servers. It's really neat. So two things I want to highlight here. This is what a static map call looks like. And it is just going to, yeah, so this is now, you can see I can drag it around. This is just a static ping. And here's how it's invoked. And there's a few things to note here. First, this is the style. I'm just using our default streets style because frankly, I'm not that good of a cartographer. And it's a very attractive style to begin with. The second is I'm using the overlay capability, which lets me put a pin and an icon from our Mackie data set on that and set the color. So you could, if I just modified this color a little bit, I would get a totally different pin. If I modified that lat long, I would get it in a different location. If I change this to barbecue, it looks like I'm throwing a party. This is just like a very easy way to tweak what you want. And it's all there in the docs, as you can imagine. The other thing I want to highlight about this, though, is that it's very nice to use with the Python request library, which is sort of the default for how people use the, well, they often avoid the built-in Python HTTP request libraries. All I'm doing here is passing longitude and latitude, and what comes back, I don't even have to dump this to the file system or anything. I can just put the response object in as an attachment for the pushover client, and it kind of magically comes through on all the push notifications, which is super slick. So it's really, really easy to throw static maps into your API if you've got lat long and you want to deal with push notifications. Okay, and then the last thing you may have noticed from this, what am I going to do with the meter, right? So I should have explained this up front. The light goes on when the car is moving. The LED is it turns from green to red based on how fast the car is going, and then this meter shows how many minutes away it is. Figuring out how many minutes away the car is it's tricky, but fortunately, other people have done the work for us and built this directions API that we can query. So all that I do for the directions API, well, let me say, the directions API can do all kinds of stuff, right? It can give you multiple routes where you want to go. It can hit waypoints for you. I am sadly ignoring almost all that functionality and making a really dumb request whenever I get a new lat long. All that it is doing is saying, here is where the car is right now. Here is where I know my house is. Can you please give me directions? And I am using this duration value in seconds, throwing absolutely everything else away. The other thing to highlight is I'm using the traffic profile, right? So this is informed by our real-time traffic data to give a pretty good estimate of how long it's going to take for the car to show up. All I do is divide this by 60 and then send the number of minutes out. So those are the three APIs. And these get combined into a set of information that makes sense, and it gets pushed out to my watch and my phone and my wife's watch and phone, and to this MQTT server, which I will now attempt to live demo, which which is listened to by these devices for changes. So let me make this window a little bit smaller. Let me try and split this up. So this will just be kind of I'm going to use some command line tools for accessing the MQTT server. You can access it using bindings in pretty much any language. The server I'm using is called Mosquito. It's an open source project. I think the Apache Foundation maintains it, and it's great. It works fine. So first, I'm going to subscribe to a topic. I'm going to say we're going to localhost, and I'm going to subscribe to track car moving is the name of the topic. It's just going to sit there. One just means, okay, I connected. And now I'm going to publish something. I'm going to publish a fake message to that topic. And again, same box. Oops, a little bit of lag. And I think the 0 turns it on. So I got a 0 in that right window, and there it goes, bang. Little latency on the Wi-Fi streaming cam, but you can see it's pretty much working. Let's mess around with the other ones. So it's not a very consistent naming scheme, but I'll go ahead and do ETA, and that should move the needle. There it goes.
That is so great.
And last one, let's this takes an RGB value, so I'll go ahead and make it red. There we go. That's it.
Oh, that's cool. So it's blue when it's not moving, and it's red.
Yeah, exactly.
So what is
So
it
awesome.
for you in the morning when you see this? That's like, I need to finish breakfast and get these kids dressed.
Yeah, more or less, or it's more like I'm making breakfast and I really like I saw a snippet of an email I really need to pay attention to, and then that yellow light turns on. I'm like, okay, 20 minutes or so. Like,
That's great. We had some other fans of Automatic in the chat before. I don't know if any of them ever connected it to a hardware device like this. I'd be super curious. So if anybody has done something similar, let us know in the comments. And while we're kind of waiting for that, you know, I kind of love this presentation just because this is really the element of play, right? Like this is connected to your day job in a way, but this is also you know, figuring out how to solve a problem in your personal life and doing it in a playful manner. Like you could have just had an app and like done that, but you really enjoy, you know, using hardware and figuring out how to modernize it. And seeing that voltage meter raise, like the other day, I was like, that is so impressive, seeing this really old piece of tech, you know, receiving commands from a Raspberry Pi server. I think that it's just really, really interesting, the combination there. So that's kind of a comment, but one of the questions is, you know, how dissimilar is what you just showed us, this architecture, to what some of our enterprise customers are doing? Like how different or similar is what you just showed us to an organization that wants to track, you know, their tractors or their rental equipment, for an example?
yeah, so I should say, you know, the Sinotrack people and this market generally, there's a bunch of different adapters you can get. The ones, if you've got a fleet, you're probably not using one that plugs into an OBD2 port, which is limited in various ways because you don't want to make your car's system bus super hackable through this thing that anybody can plug something into. But if you're willing to do some rewiring under the steering wheel, you can get something that plugs in and has a lot more data and will send packets much more frequently than 30 seconds. Although this one can be configured to send its location much more frequently too, if you send that, you know, crafted text message. In a fleet circumstance, you are probably logging different metrics, right? So I do record all of my trips as GeoJSON, stick them up into an S3 bucket in case I want to do something with them later. But you're probably, you know, looking at compliance with the speed limit. You are probably using the Mapbox Matrix API to figure out where your drivers ought to go to make the various stops that they've got to make throughout the day in a maximally efficient way across all the stops and all the vehicles. But, you know, broadly speaking, this idea that you're pushing latitude and longitude over a cellular network to a server that's then going to do clever things with it. Yeah, that's the basic pattern.
Love it. I love it. I just asked in the chat if anybody else has done any other like COVID projects or hobbies. I feel like that's the trend. If people are you know, kind of lucky and able to have some time, I think a lot of people have been exploring things. So maybe this gave some people some ideas. We'll see if they're writing to us.
I should say, like, as stretch goals, there's a bunch of things I could be doing better here that like the Automatic people did do, but I didn't want to mess with. So one obvious one is having a real map instead of a static image, like one that I could pan around. That'd be really cool. But I didn't want to have to worry about the security and privacy stuff, right? Like, it's not too terrible to set up a login system, but I didn't want to have to deal with that really. Like all the auth is taken care of. There's nothing that really exposes any security surface area. And then the directions stuff, I actually do get the bearing of the car from the adapter. So that's, you know, not just the position where it is and how fast it's going, but what direction it's going in. And you can feed that into our API to get a better sense, right? Because like if you need to turn around on the highway at the next off ramp, that's going to really change your ETA. But I don't bother with any of that. And the API will definitely take that input if you don't want to mess with that. But if you can provide the bearing, you will get a better result. And I just haven't gotten around to doing it yet.
Yeah, totally. We do have a couple of comments. WearGrid said that they were thinking about doing this with Translock, another Mapbox customer, which is kind of cool, to figure out when the bus was on the way. So kind of a similar, help is on the way. It's time to start another portion of your day. And then they actually have another good comment though. They said they're pretty new to playing with our APIs, but they like it so far. When we were talking earlier this week, my question was like, how else would you have built this? If you didn't use Mapbox, who else would you build this with? Because I work with our customers a lot, and to provide a solution, right? Like we try to give them a whole, picture of the landscape, and not only positives and negatives, but like a total package, right? So if you didn't use Mapbox and you didn't work here, who would you have used, or maybe why did you use Mapbox regardless?
Yeah, so I guess you got to break it out into different pieces. I should say I have the least familiarity with competitors' directions APIs. And let's just assume for the sake of argument that you'd be in compliance with everybody's terms of service, which is like maybe not a good assumption to make. So the directions API, I couldn't say, right? There are other people with these things out there, and you might be able to get a number of seconds ETA from them. For geocoding, you could definitely use, there are a lot of different folks with geocoding out there. The one that immediately comes to mind is Google Maps. The big downside there is that to authenticate against any Google APIs, which you have to do so that they can keep track of your usage and say when they need to start sending you bills, you have to auth with OAuth, which is it's a sophisticated way to authenticate against an API. It's also a huge pain in the ass, particularly if you are like writing a script. The OAuth workflow is really designed to have a web browser involved. If you've been trying to get permission from one application to another, and it's like kicked you out to Twitter and said, this thing is going to be able to read your timeline, but not tweet, click allow or not, that's the OAuth workflow. And there are hacks to make it work when you're just writing like a console script, but they're not fun. The Mapbox, we use JSON web tokens to authorize you, and it's just a lot. The ergonomics are a lot better for something like this. And then for static maps, I honestly don't know. Like you can definitely generate static maps from geodata using stacks like Mapnik. They are minimally a day to configure. Certainly if you want something that has the kind of like styling flexibility we do in Mapbox Studio, and then to be able to like either use that to power a GL web view or dump out static maps, I don't think anyone else does that.
And we have an awesome question from Michael in the chat. So Michael doesn't know this, but Tom and I discussed this exact problem too. We used to live 2-3 streets apart from each other in the same neighborhood. And part of that neighborhood, and most of DC in general, is street cleaning. It's a huge pain. It happens like twice a week, at least on my street. And if you don't move your car, you get a pretty nice sized ticket, even if they don't clean the street. So Michael asked, can you configure custom street cleaning zones? So you'll get a push notification and you need to move your car the night before.
Oh man, this is a fantastic question and also a huge can of worms, but it connects to my policy work. So you're gonna have to bear with me for a sec. So first, some caveats. The quality of the GPS signal you get from under your dashboard is not always the best. I occasionally get a push notification in the middle of the night telling me my car is being stolen because like there's been an echo that bounces off of an apartment building next door or whatever. So you want to be aware that you may not have the precision you need from one side of the street to the other. In general, I think you do though. Your phone like uses Bluetooth and Wi-Fi and all kinds of other sensor fusion stuff to give you a really good fix, but like GPS, unless you got fancy hardware, is actually pretty error prone. But with that said, I think you could do it. Here's the other tricky part though. Cities don't actually, they not only don't have the data that defines where street sweeping is, they don't know, right? It's not just they haven't turned it into, turned a bunch of PDFs into files. It's that like whether the sign is on the street is their canonical record of whether someone gets a ticket or not. It's real bad. People are working on this. As you might imagine, this has become like how you can use the curb has become a subject of great interest as cities have started dealing with ride sharing and other new business models. And there are organizations like Shared Streets that are working on creating detailed data specs for this. And I am pleased to say that the lovely bureaucrats at DC's Office of the CTO, Octo, have been working on this exact problem and have a draft release of street signage data, including street sweeping information. It is like a hilariously complicated problem compared to what you might have in your mind. Certainly that was true for me anyway. But yes, I think that city by city, you could do this. And if you were content to just do it for like your street where you're putting in the street sweeping data manually, then yeah, that's not too hard.
Yeah, to counter, if you know that you park at your house, at your best friend's house, and at your mom's house, you know the street signs, you can draw a bounding box in Mapbox Studio, presumably, or you could use a command line tool and then have that as a data point within your model. Is that pretty accurate?
Yeah, that's right. And actually TrackCar does geofencing. That's one of the things it's pretty good at. So you could use that without writing any code if you wanted to.
So there you go, Michael. We just saved you like a couple $100. So we'll bill you after, but don't worry about that. All right. This one's on the house.
But yeah. And this is a great, it's a great candidate for a DIY project because like the problems I just described are why companies like Automatic didn't offer this service. But yeah, to your point and his point, Sean, if you're just, in the market for a solution for your neighborhood, it's something you can do yourself pretty easily.
Yeah, save San Francisco and build it, and then we'll tweet it and we'll give you tons of press about it. We would love that. Half of our office is out there, so you would solve a lot of problems for people, I think. Awesome. And then, this is a really good question too. We talked about this earlier in the week, but we didn't talk about it today. Dom, do you want to ask your question?
I'm like, how much does it cost? You got a SIM card in the hardware in the vehicle, right? So like, what service is it on? Like, how much do you pay for that?
I forget the name of the service. How much I pay is nominally $5, but we'll see what these guys do with my credit card. Basically, like the notes on the Amazon page for the Sinotrack say, works great with this provider. And I went and looked at them. It's like, yeah, that looks fine. And they, I signed up. It's $5 a month. They mail you the SIM card and it's easy. There's probably even cheaper alternatives out there. The keyword you might want to carefully put into a search engine is M2M for machine-to-machine SIM cards. But yeah, that's like that's what you're looking at. One other idea which I'll throw out here, if you are just interested in the I've seen someone note that Twilio will do SIM cards for $1 a month. I forget the details, but there were people on the TrackCar forums discussing why the Twilio SIM plan was not adequate for this. And I'm not sure why. It may be that it didn't do data. But if you can unlock this and save me $4 a month, I'd be delighted. The other thing you could do though, I don't know if folks are familiar with LoRa, L-O-R-A. This is a really cheap long-range radio technology that's very Arduino compatible. Under good circumstances, it can transmit at low baud rates for surprisingly far, certainly hundreds of meters. They claim even up to 1 kilometer if you've got good antennas. So if you're just doing something on your street, you might be able to just power something that collects GPS and then spits it out over a LoRa signal to your base station at home without paying anybody. Worth a shot. These things only cost about $10 per transceiver.
That's awesome. And then this is just like I don't even know the answer to this. Since Automatic went belly up, is there anybody that's kind of providing this out of the box right now, or is it really only DIY, build it yourself, or go to like a legitimate vendor of fleet management software?
There are a lot of different folks who do this actually, and I started to research them. So Automatic made a splash because they had a really good deal where you could buy the adapter and get like lifetime cell service on their gold plan. And they also had like good marketing and web design and were generally pleasant to use. There are a lot of companies that do the same thing for like you just bought your kid their first car and you want to make sure they don't like drive 100 miles an hour. Or parents who are starting to get forgetful, you want to be able to help them out in an emergency. So those are the two markets that these things target. I didn't research them super thoroughly. I was looking pretty carefully at one called Vyncs, V-Y-N-C-S, that seems to do a good job, but gave me a kind of terse reply when I asked if they would open their API to me, and that's no good. But they do have an API for fleet applications. So yeah, there's a lot of folks. They are frankly all pretty expensive. They are typically an annual fee in the, a couple $100 is not unusual.
All right, and we got a, let me check this out. We got a question of, is this the GPS tracker that you're using? Sinotrack.
Looking at, yeah, so this is on my, I'm looking at Twitch on my phone, so I don't think I can verify for sure. But I think it is. My advice though, if you're looking at this, so I don't necessarily recommend the Sinotrack specifically. There's a bunch of roughly equivalent things at the same price point. Go to the track car wiki. There's a long list of adapters there, and an even longer list of forum posts talking about whether they're compatible fully or not. The thing I really don't like about the Sinotrack is that it does not tell you when an ignition event occurs. So the automatic would tell me when the car stopped or started, when the engine stopped or started. So it was through the same interface. So I know it should be able to get that. The Sinotrack does not. So I just look at the GPS and like guess whether it's moved enough that it's a real trip starting or not, which means there's kind of a delay before I get that event that I didn't used to have. There may be other adapters that do a better job of this. I would say check out the track car list of supported stuff. It's very long, doesn't have a ton of detail, and then like look through their forums to see if there's any problems with the one that you're eyeing, or maybe there's just like a list of recommended adapters. That's where I would start if I was doing this over again.
Nice. Nice. Hypothetically, could you build this with, instead of a car first approach, like a mobile SDK version where you're getting GPS pings from device, and then you compare that to like a bounding box, using our Isochrons API as an example to get notifications? Could you do something like that too?
Yeah, for sure. There are, I did a kind of similar project using a little iOS app that I built that was, I don't know if you all have ever seen this. There were some weirdos in the UK who took measurements of how much space cars that were passing them on their bicycles gave them. They used a little ultrasonic rangefinder. It was not very scientific. They were trying to evaluate whether gender had an effect on how much space you were given, but the way that they tested that was by having the guy wear a blonde wig or not. So I'm not going to say it's like the most scientific thing, but it looks sort of fun. Yes, okay, Sean's got one there. Awesome. Yeah, so that's a little ultrasonic rangefinder. And I built a little thing that talked to an iOS app, recording those distances while the iOS app on my phone collected GPS traces. And then I gave a talk about this at a bike hack night, which we can link to if people are interested. So the short answer is yes, you absolutely can do that. You don't need to use these pre-made adapters. If you buy all the different components, it's gonna be a little bit more expensive probably, but we're still talking like 150 bucks if you bought an Arduino or one of these ESP chip-based ones, a GPS receiver for the Arduino. That's probably gonna be your biggest single line item, and then some backend to get the data off. If it's in real time, you will need either a cellular modem, which again could be, it's going to be more expensive than the integrated solution, but still plenty affordable. Or you could do the LoRa radio thing if you're just content to get the data when you're within, a few blocks of wherever you're setting up your receiver.
Awesome. And where Grid asked, might have missed it, but is the analog meter just something you can pick up at Adafruit or SparkFun, or something and attach the I/O pins on the Pi? It doesn't have much experience with DIY hardware.
That is a great question. So short answer is no. If you go to, I got all these off eBay. If you go to eBay and search for vintage meter, you will occasionally find these. I just had to like keep an eye out and buy them. And you'll get a bunch of stuff that looks awesome like these, and a bunch of stuff that's like old junk. Hang on one sec while I grab a visual aid. You do need to be slightly careful about this.
Tom Lee has become map data. He is baked into the base map.
That's right. So a lot of these were like vintage equipment from different contexts. And this one is particularly lovely, but also is not a voltmeter. This is a watt meter, and a watt meter is designed to measure like a lot of watts, and there's no real way to make it sensitive to a small number of watts. That's not true about a voltmeter. So the voltmeter, basically what's doing is it's got this needle on a spring and a magnet in a little electromagnetic field that gets stronger or weaker. And there's a resistor so that the input voltage actually doesn't have to be very high. It's an extremely sensitive device. You're throwing away most of the voltage. So what you can do is just, even if it's designed to like measure, Frankenstein level giant bolts of electricity, you can just get rid of that resistor and replace it with one that's appropriate to the tiny, tiny amounts of electricity that your microcontroller is spitting out. It's not that hard to do. You just want to like be conservative so you don't blow out the mechanism. And really what you want to do is use a variable resistor. It's called a potentiometer in your circuit. And on the microcontroller side, the way that this works is these things don't actually have the ability to vary voltage levels. What they do is they chop up the voltage really fast. So they turn on and off really fast. You can imagine if the output of an Arduino is 5 volts normally, it can chop up that 5 volt signal. So imagine that it's like every, I don't know, 10 millionth of a second, it can chop up that amount of 5 volts into 256 different windows. And if it turns on half those windows, you're going to get out 2.5 volts. And if it turns on 20%, you're going to get 1 volt. And it's just like, it's so fast that if you measure it with analog equipment, it looks smooth. This is the same way that like your, speakers in your computer work and lots of other stuff. It's called pulse width modulation. And so that's what you do. You basically like take the output of your microcontroller, you set the PWM, pulse width modulation, to be maxed out to its output voltage. And you start with a resistor turned way the hell up so that almost no energy is going into the voltmeter, and then just slowly turn the potentiometer to let more through until the needle starts going up. And when it goes all the way to the top of the range of the meter, then you're like, I got it, I'm fine. Now, the one other caveat I'll offer is that, and I want to be mindful of time, so I'm sorry I'm going down this rabbit hole, except that I enjoy it, is that the response may not be perfectly linear. So some of the code that's running on that Raspberry Pi lets me calibrate it, right? So I make sure that if the PWM is at 50% duty cycle, it actually goes to 50% on the meter. That's not necessarily guaranteed. It really depends on the hardware, and these things will drift over time. So it's another good reason to have a potentiometer, right? Like I hadn't used this meter in a couple of years. Everything was like slowly aging, including the author of the hardware, and I needed to recalibrate it when I started using it. But it'll hold steady for a while. Like it all just varies based on it, and it's kind of like baked into the cake when you're dealing with vintage stuff.
All right, we have one more question in the chat, and then I have one final question for you. All right, so I'm going to give you the chat, and then I'm going to give you my question. It's more of a comment from Michael, just asking, are you familiar with homeassistant.io? It might help as a platform to integrate your MQTT server, track card, everything else. Are you aware?
I'm not. I will say, like, this project was a great way to get familiar with MQTT. It is, I've come to realize, the basis of every home automation technology out there and like IoT platform. I had stared at like, I like this hardware hacking hobby, and I feel like I should have a dim awareness when I go to the Amazon Web Services IoT page, like, what is this? What could this possibly do for me? And now I realize, oh, they're rebadging an MQTT server, probably Mosquito, with some Amazon authentication goodness. Okay, great. And the same thing goes for, I don't know Home Assistant, but I know there's like HomeBridge to help you connect the Apple home automation stuff with Alexa and all that other stuff. Those projects are awesome, but what I will say is if you have the ability to write even a little bit of code, it is way more empowering to do so rather than to like click through a zillion GUIs to get this stuff set up. A related project, like the one that I went to after I finished this, was there's a really cool infrared, they call them, it's ridiculous, they call them IR blasters in the like home theater industry. It's basically like if you want to automate things that an infrared remote control does, this is what you would get. And that same chip that I showed off at the very beginning, the ESP 8266, that with the addition of one infrared LED turns into like an IR blaster you'd normally be paying some quack from Crutchfield hundreds of dollars for. And yeah, you can like connect it to Alexa, you can connect it to your MQTT server, you can do all kinds of cool stuff. So yeah, anyway, this is just a plug for like, if you can write some code, definitely start there.
That's it. All right, and my final question for you before we wrap up, I know that we're at 45 minutes. Has this made your life any better? Has this relieved the pain of COVID and having children to manage?
Mostly yes. I was explaining it actually increased the pain a little bit because someone at our daycare got a positive test. We're all negative, I'm pleased to say, but it shut down and we were in quarantine for 2 weeks, which means we didn't drive anywhere, which means this thing was sending pings off the car battery every 30 seconds until I couldn't start the car yesterday. So be aware of that. I've charged the battery, everything's fine. But yeah, until then, yes, it made my life dramatically better.
All right, I'll give you a jump. Very good.
Great last question and answer. All right. Well, if anybody's looking for a recording of this episode, make sure to go to mapbox.com/webinars, sign up for this webinar, and we will email you a recording tomorrow. And you'll also be able to see the upcoming webinars that we have, one for Mapbox tiling service and another one for offline routing for Android, how to build a basic offline routing application. So this was amazing. Tom, thank you for sharing this with us. And Sean, thank you for doing a great job moderating today. Everybody have a great rest of your week, and
Pleasure.
Don't drain your car battery.
Thanks,
Make
Tom.
the meter wave goodbye.
Yeah, yeah, show us the light. So good.
All right. See y'all
Thanks, Tom.
later.
Bye.
Bye.